Assalamu alaikum.
Walaikum assalam, sir.
Today we will learn about the small changes and the use of differentiation to calculate the small changes.
Okay, sir.
There is a curve y is equal to x square. You are well familiar with this curve. This one is y square. This one is a point 3, 9. When we will put x is equal to 3 into the equation y is equal to x square, we will get 9. This point is P. The tangent at this point is
P, sir.
the tangent at this point is this line. This one is the tangent to the curve at point P. Now take another point Q on this curve. This one is point Q. This one is point P, this one is point Q. A straight line joining the 2 points of the curve is known as secant line. A straight line joining 2 points of the curve is known as secant line. Now this one is a line joining these 2 points P and Q. This one is known as secant line. This line is known as secant line. Now, the definition of the secant line is a line joining two points of a curve. Now, what is the gradient of the tangent line? The gradient of the tangent line is dy over dx is equal to 2x, and dy over dx at x is equal to 3 is 6. The gradient of the tangent line is 6. Let the points Coordinates of point Q be 3.1 and the value of y is 9.61. When we will put x is equal to 3.1 into this curve, we will get y is equal to 9.61. Now we will draw a table. We will take P as x1, y1. Here x1 is 3. And we will take point Q as x2, y2. x2 is 3.1. x2 minus x1, change in x is 0.1. Now y1 is 9, y2 is 9.61, y2 minus y1 is 0.61, and then y2 minus y1 over x2 minus x1, that is the gradient of the secant line, is 0.61 divided by 0.1 is 6.1. Is there any question?
No, sir.
Now I will move this point Q close to point P. That is, I will take the x coordinate of Q as 3.01. I will move this point Q close to point P and let the, now the x coordinate of point Q is 3.01. P point is same and its x coordinate is 3. Now change in x is 0.01. Y1 is same, 9. This one is x1, y1, 9. Now y2, x2 is 3.01. We will put 3.01 into this equation to get the value of y. The value of y is 9.0601. Now change in y, y2 minus y1 is 0.0601. And when we will divide y2 minus y1 with x2 minus x1, the gradient of the secant line is 6.01. Now we will move point Q more close to point P, and the x coordinate of point Q is 3.001. X coordinate of point P is same, that is 3. Now x2 minus x1 is 0.001. y1 is same. We will put x is equal to 3.001 into y is equal to x square, and the value of y is 9.006001. The change in y is 0.006001, y2 minus y1, and the gradient of the secant line now is 0.6001. Now I will move point Q more close to point B by taking the value of X as 3.0001. The change in X is 0.0001. Y1 is same. Now the value of Y is 9.00060001, and the change in Y is 0.006001, and the gradient of the new secant line is 6.0001. The new secant line is now this. I will draw the new secant line. The point Q is very close to point P, that is at this place very close to point P. Point P and Q are very close to each other. Now can you see that the secant line will become the tangent line? This one is the secant line. Can you observe that when point Q is very close to point P, the secant line is the tangent line?
Yes, sir.
And you can see that from the gradient, that the gradient of the secant line is approximately equal to the tangent line.
Yes, sir.
When change in X is very small, when change in X, this change in X is very small, then the gradient of the secant line is the gradient of the tangent line. When change in X is in X, we will denote this change with del X, is very small. This one may be denoted by del Y over del X. When change in X is very small, gradient of the secant line is the gradient of the tangent line. And mathematically, we will write down this del Y over del X is approximately equal to dy over dx when del X is small. Dy by dx is approximately equal to dy by dx when del X is small. When del X is very small, the gradient of the secant line is approximately equal to the gradient of the tangent line. And this one is the result we will use to find the small changes. Del Y over del X is approximately equal to dy by dx when del X is very small. These questions are from exercise 16.3. We will use the rule del Y over del X is approximately equal to dy over dx. Now the question is given that y is equal to 2x cube minus 4x square. Find approximate change in y. Find approximate change in y. Find approximate change in y. We want to find del y. When there is a word approximate, means a small change. We want to find out del y. As x increases from 1 to 1.05. Now what is the change in x? Del x is equal to 1.05 minus 1. The change in x is 0.05. We will always find the change with the help of new value minus old value. New value minus old value. This one is the method to find out the change. Del x is 0.05. Now we will use this rule. We want to find out del x. We want to find out del y. We have the del x. Now we will find out. Can we find out dy by dx of this curve?
Yes, sir. Sir, the dy by dx of this curve will be dy over dx is equal to 6x square minus 8x.
8x. Now we will put original value of x into the derivative. Original value is 1 and the changed value is 1.05. The original value
So,
is,
sir,
we
1,
will
sir.
put x is equal to 1 and this one is 6 minus 8 is equal to minus 2. Now we will use this rule, del y over del x is equal to dy over dx. Del y over del x is approximately equal to dy over dx. We want to find out del y. Del x is 0.05. Please hold your calculator. And dy by dx is minus 2. Del y is equal to minus 2 into 0.05 and the answer is 0.1 negative. It means that if there is a small change of 0.05, if there is a small change of 0.05 in x, then the change in y is minus 0.1. Y will decrease by 0.1. Okay. If there is a change in x of 0.05, then the change in there is a decrease in y and the change in y is minus 0.1. Okay. Is there any question?
No, sir.
Now we will attempt another question. Now this one is question number 3, exercise 16.3. Now the basic rule of the small changes is del y over del x is approximately equal to dy over dx. Now in this question, we have given that y is equal to 2 plus 8 over x. We will simplify this one, y plus 8x power minus 1. Find the approximate change in x. When there is a word approximate, it means we will use the rule for small changes. Find the approximate change in x. So del x is equal to question mark, which will cause y to increase from 6 to 6.01. Del y. The method of finding the change, finding the change is
Sir, is to subtract the new value from the old value, sir.
no. Old value from the new value. New value minus old value 0.01. Now there is a word approximate. We will use the rule del y over del x is approximately equal to dy by dx. For this we should have dy over dx. So dy over dx is equal to 0 minus 8x power minus 2. Dy over dx is equal to minus 8 over x power 2. Now we have the original value of y, but we will put value of x into the derivative. We have the derivative in terms of x. First of all, now we will find out the value of
X, sir.
x. We have 6 is equal to 2 plus 8 over x. 4 is equal to 8 over x. X is equal to 2. Now we will put this x is equal to 2 into the derivative. This one is minus 2. Now we will write down the rule for small changes. Del y over del x is approximately equal to dy over dx. Del y is given 0.01. Del x is unknown. And dy by dx is minus 2. So 0.01 over minus 2 is equal to del x. Now del x is equal to minus 0.005. Now, if there is a change of 0.01 unit in y, there is a change of 0.01 unit in y, the change in x is minus 0.005. Is there any question?
No, sir.
Now we will move to the next. The next question is from exercise 13.6. 16.3. Question number 6. Use calculus means differentiation to determine approximate change. Small changes. For small changes, we use the rule del y over del x is approximately equal to dy by dx. In the area of a circle, in the area of the circle, small change in the area of the circle, del A is equal to question mark. When the radius increases from 3 to 3.02, del R is equal to find out the change, the rule is new value minus old value. 3.02 minus 3 is equal to 0.02. Now, in the question, he is giving the information about the area of the circle. So we will write down the formula for the area of the circle. A is equal to pi r square. Now, as there is a change in del A and del R, now this rule, we will modify this rule to del A over del R is approximately equal to dA over dr. Now in this new rule, new modified rule, we want to find out del A, we have del R, we will find out dA over dr. We will apply d over dr on both sides. dA over dr is equal to 2 pi r. Now we will put the original value of r into the derivative. The original value is 3. R is equal to 3. So this one is 6 pi. Now we will write down the formula for the small changes. That is del A over del R is approximately equal to dA over dr. Del A is unknown, del R is 0.02 and dA over dr is 6 pi. So del A is equal to 0.12 pi cm square. Now, if there is a change of 0.02 units in hour, the change in A is 0.12 pi centimeter square. Is there any question?
No, sir.
Now we will attempt question number 15 of exercise 16.3. Here we have y is equal to x power 1 by 3. Use calculus, differentiation, integration to determine the approximate value for cube root of 1003. Now you can see that in the above equation there is cube root of x, and in the value given there is a cube root of 1003. At the place of x it is written 1003. Now Muaz, think about a number which is very close to 1003 and which will give a exact cube root.
Sir, 1000, sir.
Yes, 1000. Now the new value of x is 1003, and original value which gives you the exact answer is 1000. Now del x is new value minus original value is equal to 3. Now we will find out del y in this case, and then we will use del y to find out the value of cube root of 1003. How? I will explain this. To use the small changes, we will have to use this rule, del y over del x is equal to dy over dx. For this, we should have dy over dx. So dy over dx is equal to 1 over 3 x power minus 2 by 3 is equal to 1 over 3 x power 2 by 3. We will put the original value of x into this expression for dy by dx. 1 over 3 10 power 2 by 3. Sorry, 1000 power 2 by 3. Original value is 1000. What is the final answer? Please choose calculator to find out.
Sir, 1 over 300, sir.
1 over 300. And in decimals, the answer is?
Sir, 3.33.
Sorry,
Sir, 3.33.
into 10 power. Dy by dx is at x is equal to 1000 is 1 over 300, that is 0.00333. Now we will find out del y. Del y over del x is equal to dy over dx. Del y divided by del x is 3 and dy by dx is 1 over 300. Del y is equal to 1 over 100 is equal to 0.01. Now, what is the original value of x?
Sir, the original value of x is 1000.
What is the change in x?
1000, one, sir, sorry, sir, 3.
3. What is the new value?
Sir, 1003.
Yes. What is the old value of y?
Sir, the old value of y is, sir,
Put x is equal to 1000 into the equation and get the old value of y.
10, sir, 10, sir.
10. What is the change in y?
Sir, the change in y is 0.01.
So what is the new value of y?
Sir, 10.01, sir.
10.01. So when the value of x is 1003, the value of y is 10.01. With the help of small changes, we came to know that cube root of 1003 is equal to 10.01. Is there any question about this?
No, sir.
Okay. Now we will attempt another question from this exercise. This one is question number 19 of exercise 16.3. The function y is defined by y is equal to 12 minus 4x plus 5x squared. Write down the derivative. Write down the derivative. Okay. Dy by dx is equal to minus 4 plus 10x. This one is the derivative. And show that when x is equal to 6, a small increase in x of p%. Small increase in x of p%. Small increase del y over del x is equal to dy by dx in x of p%. Del x is equal to 6 into p over 100. The value is 6 and the change is p%. So del x is equal to 6 into p over 100. Is there any question?
No, sir.
Cause an increase in y of approximately 2p%. We want to show that del y is 2p%. Del y is 2p%. So we will use del y over del x is equal to dy over dx. For this, we will put the original value of x into the derivative, which is 6 minus 4 plus 10 into 6 is equal to 56. This one is the dy by dx. Now, del y over del x is approximately equal to dy over dx. Del y over 6p over 100 is approximately equal to 56. Del y is equal to 56 into 6p over 100. And what is 56 into 6? Moss.
Yes, sir.
What is 56 into 6?
Sir, it's 336.
56 into 6. Acha, 336. Okay.
Yes.
336. Okay. Now, keep it in your mind that if the change in x is in percentage, then the change in y should also be in the percentage. Now, we will find out percentage change in y. Percentage change in y is equal to change over y old into 100 is equal to del y is 336 over 100 into p over what is y old. Put x is equal to 6 into y. 12 minus 4x plus 5x square and give me the final answer, please. Now, by putting x is equal to 6 into the curve, we will get 168
Yes, sir.
into 100. Now, this one is 336p over 168 into 100 into 100 is equal to 2p%. Now, if the change in x is in terms of percentage, then we will give the change in y in terms of percentage. Okay. Now remember this. If the change in x is in terms of percentage, then we will give the answer of change in y in terms of percentage. And the formula for finding the percentage change is this, that is change over original into 100. Is there any question?
No, sir.
Okay.